A traffic light may look like a simple box with three colored lights, but behind those lights is an electrical system that controls the movement of vehicles and pedestrians at intersections. How does it know when to change from red to green? How does it decide how long each light should stay on? And how does it prevent two directions of traffic from moving into each other? To understand this, we need to start with the basic purpose of a traffic light. A traffic light is a signaling system that controls who can move and who must wait. At an intersection, vehicles may be traveling from different directions, while pedestrians may also need to cross the road. Without a system to organize this movement, vehicles could enter the intersection at the same time and create conflicts. The traffic light solves this problem by giving each direction permission to move at the right time. The most familiar traffic signal has three lights: red, yellow, and green. The red light means stop. When drivers see red, they must remain behind the stop line and wait. The green light means go, but only when the road ahead is clear and it is safe to move. The yellow light means the current green phase is ending and the signal is about to change to red, so drivers should prepare to stop when it is safe to do so. These three lights work together as a repeating sequence, but the lights need something to control them. This is where electricity comes in. Electrical power is supplied to the traffic signal system through the local power network. The electricity provides the energy needed to operate the signal lights and the electronic equipment that controls them. Modern traffic signals commonly use LEDs, or light-emitting diodes. An LED produces light when electrical current passes through a semiconductor material. Because LEDs are efficient and can produce bright light while using relatively little electricity, they are widely used in modern traffic signals. But supplying electricity to the lights is not enough. The system also needs to decide which light should be on and when it should change. This is the job of the traffic signal controller. The controller is an electronic device usually kept inside a control cabinet near the intersection. You can think of it as the brain of the traffic light system. It receives information, follows programmed instructions, and sends electrical signals to the traffic lights. When the controller tells the red signal to turn on, electricity flows to the red LEDs, making them light up. When it tells the red signal to turn off and the green signal to turn on, the electrical signals change accordingly. The controller repeats this process, following a planned sequence. In a simple traffic light system, the sequence may begin with one direction receiving a green light. Vehicles traveling in that direction are allowed to move through the intersection. After a set period, the controller ends the green phase and activates the yellow light. The yellow phase gives drivers a warning that the current movement is ending. After the yellow period, the signal changes to red. Now the traffic moving in that direction must stop. Once the first direction has been stopped, the controller can give the other direction a green light. That direction then follows the same sequence: green, yellow, and finally red. The process continues repeatedly. The exact timing depends on the intersection and its traffic conditions. Some traffic lights use a simple fixed schedule. In this type of system, the controller is programmed with specific time periods. For example, one road may receive a green signal for a certain number of seconds, followed by a yellow phase, and then a red phase. The other road then receives its green signal. This cycle continues throughout the day. However, traffic conditions are not always the same. A road may be busy during the morning and nearly empty at another time. This is why some intersections use vehicle detection systems. These systems can detect vehicles waiting at the intersection and send information to the controller. One common method uses sensors installed in the road. These sensors can detect the presence of a vehicle waiting above them. Other systems may use cameras, radar, or other detection technology to monitor traffic. When the controller receives information from these sensors, it can use that information to manage the timing of the traffic signals. For example, if one road has many vehicles waiting while another road has very little traffic, a traffic signal system may adjust the timing to help manage the flow. The exact behavior depends on how the intersection has been programmed. The traffic light system also needs to work with pedestrians. Many intersections have pedestrian crossing buttons. When a person wants to cross the road, they can press the button. This sends a signal to the controller. The controller then processes the request and, when the correct stage of the traffic cycle arrives, activates the pedestrian crossing signal. At the same time, the traffic lights are coordinated to stop vehicles that would conflict with the pedestrian crossing. The pedestrian signal may show a walking symbol when crossing is allowed and a flashing or steady hand symbol when pedestrians should wait or prepare to stop. Some crossings also produce sounds or vibrations to help people with different accessibility needs. The controller has another important responsibility: coordinating traffic from different directions. At an intersection, vehicles traveling in one direction may cross the path of vehicles traveling in another direction. The controller must make sure that conflicting movements are not given permission to happen at the same time. For example, if vehicles traveling north and south are given a green signal to move straight through the intersection, the traffic moving east and west may be stopped with red signals. Once the north-south movement ends, the controller can stop that traffic and give the east-west direction permission to move. This coordination allows different groups groups of vehicles to use the same intersection at different times. Some intersections are more complex. They may have separate signals for turning vehicles, pedestrian crossings, bicycles, buses, or other road users. The controller coordinates all these signals according to programmed rules and information from detection systems. The goal is to organize the movement so that each group receives permission at the appropriate time. Another feature of modern traffic lights is the use of LEDs. Older traffic signals often used traditional incandescent bulbs, which produce light by heating a thin wire inside the bulb. Modern LED signals work differently. They use semiconductor devices that produce light when electricity passes through them. LEDs generally consume less electrical power and can have a longer operating life than traditional bulbs. This makes them useful for traffic signals that operate continuously. Some traffic lights also have backup power systems. If the main electrical supply fails, the traffic signal may use a backup battery or another emergency power source depending on the location and design of the system. If a signal cannot operate normally, it may switch to a flashing mode or another safety procedure to warn drivers that the normal sequence is not active. The exact response depends on the traffic signal system and local rules.